Okay, so I wanted to do this example because it's talking about two different objects that are connected. So in this example, we have a rocket, a 1,000 kilogram rocket that's towing a box behind it that's 500 kilograms, and they're connected by a rope. So we're told that the rope will break if a tension of more than 400 newtons is imposed on it. And so if we are engineers in charge of this rocket, what's the maximum thrust at which we can safely operate the engine? And so what's going to be the acceleration of the rocket in the box? So like usual, I want to break this down and do some free body diagrams. In this case, we have two different objects, so we want to do two different free body diagrams. So I have here our box, M2, and our rocket, M1. So I'm going to draw in the forces on the box first. So it turns out we actually only have one force acting on the box, and that's the force of tension in the rope that's pulling it along. Here, sometimes I do tension F sub T, sometimes I do a big T. You can do it either way. The rocket has two forces acting on it. It has the force of thrust from its engines pushing it forward, but it also has a tension force from the rope pulling it backwards. And one way to think about this is by Newton's third law. If the box is being pulled on by the rocket with force Ft, then the rocket has to be pulling back by the box, has to be pulled back by the box with force Ft. Right, so equal and opposite forces. And both of these objects are presumably accelerating, and since they're connected, they have to be accelerating with the same acceleration, which we'll call A. Okay, so how do we decide what to do next? We're told that the rope will break if a tension of more than 400 newtons is imposed on it. So let's treat the simpler object first, which is the box. And let's see what happens if we give the box 400 newtons of tension in the rope. Okay, so for the box, F equals ma. So if the force is 400 newtons and the mass is 500 kilograms, then the acceleration has to be 400 newtons over 500 kilograms, or 0.8 meters per second squared. So that's sort of the maximum acceleration that you can get without applying so much tension in the rope that you break it. Okay, so that actually answers that part of the question. What's the acceleration? But we don't know yet what the thrust is of the rocket engines. So we still have to analyze the rocket. So for the rocket, we have the force of thrust minus the tension force equaling ma. So the thrust can equal tension force plus ma, and the tension force we said at maximum was 400 newtons, and ma is 1,000 kilograms times the acceleration that we just calculated. And so what we get is 400 newtons plus 800 newtons or 1200 newtons, and that's the thrust force that we're allowed to apply.